So this is a research paper that I have selected. It is improving medical speech to text accuracy with vision language pre-training model. So this is the full research paper that I have taken the key points from and summarized it in a PPT. So let's go through it. So what will we go through in this PPT? It will basically be about the brief introduction, the background study, the main contribution, the implementation details, the experimental results, as well as what conclusion they have obtained. So what is this? And oh my god, stop share. Stop it. I think I know. I think I got it. Why it's not working? Because it's on edge. Stupid edge. Doesn't have unable to work. And yeah, let's start with it again. So Zoom meeting, back to square one. Share the screen. So we have basically, I have basically taken the research paper of improving medical speech to text accuracy with vision language pre-training model. So they have briefly summarized the introduction, the background of the study, the main contributions, the implementations, and the experimental results. So what was the scope of their study? Their main focus was on converting speech into text, but their main focus was the medical domain. Mainly because there weren't many data sets available, the translation from speech to text in the medical domain was not accurate. Since the words are quite complex, um, they are not since they're quite complex and the translation is not accurate, they are not useful in the medical domain. So they tried to minimize the errors. So what is the relevance of their studies? They have introduced a new method called as MMSM, which is called as multimodal medical speech module. So it corrects the errors in the speech to text models by leveraging comprehensive semantic context information. Moreover, it is independent of the STT, so you don't have to tune the STT models. So basically, why is it used in this medical domain of radiology specifically? Because there are different kinds of medical images available along with the recorded voices of the radiologists. So it is quite useful because this main model which is there, it revolves around providing speech along with the visual, that is the images, so that the translations which are there could be connected to the image. So based on the image, whether it is relevant or not, the translations would be made. So why do we need this new model when we have so many famous models, like Facebook has created this wave to letter plus plus. Google has created cloud-based speech to text API. Microsoft has created cloud-based Azure STT. So why do we need this new model? So let's provide some background info into speech to text. So what is ASR? ASR basically means automatic speech recognition. So it's a technology which converts speech into text. So whatever I am speaking, if I was using this technology, it would convert it into text. So the ideal way was converting exactly what I speak into text without any errors. But sometimes it is not possible. So to improve that, they have created this model. So basically, where is STT, speech to text, used? Mainly in the medical field. It is basically used in clinicians who rely on typists to transcribe their voice recordings, as they have to maintain records of whatever operations they have performed. So developing an STD model for the medical domain is actually quite challenging because there are not enough data sets. Even if there are data sets, there are a lot of security reasons, a lot of privacy invasions that is not allowed. So we can't access those data sets. And if you want to use the STD models in the medical domain, you have to train the STD models to act in a certain way that the translations are correct. So that is like time consuming also. It requires a lot of resources and a lot of research. So to address this issue, they proposed a medical domain text correction method. That is the output text of the general STD system using Vision Language Pre-training Model VLP. So VLP combines the image with the text to get the correct, more accurate translation. So this is the model that they have that they're trying to they have researched upon. So they have basically passed some original text. That original text is getting passed through the speech to text model, so that STD converts it in such a way that it is not accurate. Opacification is converted to pacification. Lymphagenetic is converted into lymph-rich, and CT is converted to C.C. As you can see, the translations are not accurate. So what they have proposed is providing an image along with whatever the STD model has tried to convert it, and trying to relate the converted text to the image. So whatever text that they have converted, does it match upon this image? Does it match upon the lungs? Is it related to the lungs? Is it making sense in this domain? So based on that, they have done this corrected text, and as you can see, it is correct. This is the original text and it is matching the corrected text. So what are the ways in which they do this? So first and foremost, you require an image and you require the text. So this is the image, it is passed to the image encoder. The text is passed through the text encoder. Now there is some kind of cross attention that is created. So whatever text is there, it is matched upon with the image, and the image is matched upon with the text. As you can see, the cross attention. That is one way. The second way is whatever image is there, it is matched upon with the text and we have got the translation. Or there is no image at all. So how did they train this model? If you want to know like how did they train it, there are two types of ways. You have to test and you have to train. So how do you train this model? There were three ways that they used to train the model. One way was by randomly removing certain words and seeing if the model can understand what words it had to basically generate. The second way was randomly replacing some words, like replacing some valent or the we can say some a correct word with the incorrect word basically. And the third way was insertion. Insertion basically is randomly inserting random words in random places. So let's check their implementation. So what have they done is they have taken this image. This image is of the lungs, as you can see. This is the text that they need. And these are through the various models that they have to convert it from speech to text. So there are two types of analysis that they have done. One is a qualitative analysis, and other is a quantitative analysis. So according to quantitative analysis, they have passed this speech to text (STT) to various models to see what is the translation that they have obtained. And if you are talking in terms of quality, over here, as you can see, the different kinds of colors appear. So the blue color is the correct answers that we expect over here. This is the blue color I'm talking about. This is the red color here signifies the incorrect answers that they have obtained. So they have passed this answer is what we need. So what have we obtained from text only? They have made this mediastinal and pulmonary vascular engorgement. So this is the word that we need. And what have we obtained through text only? We have got mediastinal vascular engorgement. Let's focus more on this lower collapse. where lower collapse is made into lobar collapse is made into lower collapse, and lower collapse is made into lower lobe in ChatGPT. So what ChatGPT has done is it has tried to make its own sentences and tried to frame its own sentences with the words. As you can see, the words also are not accurate. And their proposed model has tried to get the exact words. So lower collapse, lower collapse. They have done it with STT Julius, then they have done it with various other models as well. Now let's move on to a slightly more do you say difficult text. This is what we have obtained. Text only has just given up. It has just become blank at a certain point because these words are a bit too complex. As I said, ki the medical domain, the words are a bit complex, they're not easy to understand. ChatGPT, on the other hand, just try to make its own sentences. Proposed, on the other hand, tried to mimic the same words that was needed. But as you can see, there is this word verse written in yellow. It is not the exact words, but it is slightly relevant because here what we probably need is probably slightly larger. So larger in the sense ki it is worse. So that is not correct, not exactly correct, not matching exactly, but it is slightly, as you can say, acceptable. These are the quantitative results that they have done. They have basically given an input, passed it through the various models. The one in yellow signifies the text only, and the one red signifies the proposed. As you can see that the proposed is slightly better than the text only, or at par at most. Next, they have done some comparison. For this comparison, they had to take it through the clinical trials. They had to check out like what is the clinical trials criteria. 5 means exact perfect translation makes sense. 3 to 1 on the other hand is there are some incorrect findings. As you can see, that the proposed is slightly better than the text only. So let's go and check it out. There are some cases where the proposed failed and text only was slightly better. So we have the text only. What word we need is a new consolidation or new or pneumothorax. So no evidence of new consolidation or effusion. As you can see, it couldn't catch the word pneumothorax. That's why there was an error in one of the translations. So that's why 3 points. While proposed gave the exact speech to text translation. Next, we come on to the failure. Over here, text only gave the exact translation and proposed didn't because as you can see, signs of CHF, it was signs of cancer. So it just changed it. And that's it for this PPT.